Good evening friends. So we have learned how power is fed to overhead conductors from a traction substation to feed the power to electric locomotives. So the 25 kV overhead system is a phase and our railway track is connected to the traction substation earthing system. It is acting as neutral. And in between these the load is our electric locomotives. The load is electric locomotives. As in the electric locomotives, the main winding of the loco transformer is absorbing full 25 kV, main winding 25 kV, and from there we have taken with separate winding of 650 volt for traction motors and 380 volt for auxiliary motors. Traction motor is running the locomotives, but as the voltage has reduced from 250 volt to little volt like 650 volt, 380 volt, if you reduce the voltage, the current will be more because our wattage or kVA cannot be is fixed for a particular winding. Like our bulb, if it is a 100-watt bulb, then you cannot change this with other wattage. So these two winding, traction motor winding having little voltage and taking more current for traction motors, and the current is near about 1000 ampere. 1000 ampere. Some rating is there for continuous rating and everything. So current is more in the traction motor circuit. So it is creating heat. We know the formula of the heat for creation for flowing of current is I square RT by J. It is depending upon the square of the current. As the current is more than I square RT, so it will be a tremendous heat generation in the traction part circuit. To reduce this heating effect, we are using auxiliary motors. Auxiliary motors. You see, here I have shown 13 auxiliary motors. The first one is MPH. That means the transformer oil cooling by blower cooling motor. Okay. Transformer oil cooling motor, then silicon rectifier where the AC single phase AC is converted into DC. There are two blocks for two windings of 650 volt. It is converting to DC for traction motors power supply. It is also experiencing tremendous heat, so it needs cooling. So we have used two blower motors, that is MBSI 1 and MBSI 2. Then we have used MBSL smoothing reactor for two windings of traction motors feeding circuit of 650 volt. We are using two smoothing reactor to reduce the ripple. We know the AC is a sinusoidal wave, and if you convert it into DC by bridge rectifier or by any other means, there will be a ripple, and to reduce this we are using inductive coil, that is called smoothing reactor. Means the ripple it will smooth to get as far as pure DC. Pure DC. These 5 auxiliary motors, when the loco has started, needs immediate action. So we are closing all the switches of these 3 directly. Before doing any other operation, first you close these 5 auxiliary motor switch, then you switch on the loco circuit breaker, and it will start all these things, these 5 auxiliary motors. But how it will start? It will start you know, single phase motor, single phase has no rotating flask. So what we have done, from the single phase, we have given a starting resistance. It has been shown in the yellow line. There is a resistance with a switch. When the loco is started, the switch is closed and a phase difference is occurred, and the traction motor has started to, the Arno has started to rotate. Once it will start, then no need, like our diesel engine and everything, or our car starting starter motor. So the initial stage we need this thing, and once it will rotate, then it is not required. For our ceiling fan, we are using capacitor to create the single phase to rotating flask another phase. So this is the phase difference they are creating, and it will initiate the motor. That means here is Arno. Arno will rotate and three-phase supply will flow to the auxiliary motors. Three-phase motors, all are induction motors. It will get supply from the Arno. So Loco is first energized, and this Arno will start with the initiation of the starting resistance by creating rotating flask. It will start and then it will be cut off. This resistance will be cut off. Then three-phase supply will be fed to the other auxiliaries. Other auxiliaries are what? MBR, no, not MBRH, MPH, MBS, yes, MBRH. It is a blower motor also. It is a blower motor to cool the transformer oil. Pump, MVMT, traction motor, blower motor. Traction motor is also going to be heated, and MVMT 2 and 1. There are 6 traction motors, so it will cool 3 traction motors, MVMT 1 and MVMT 2. Then MPV, pump, transfer oil pump. It also needs, sorry. MPV is the exhauster. MPH is MPH and MVI. This is for pump, but MPV is exhauster. MPV1, MPV2. Somewhere exhauster is required where vacuum brake is applicable, but nowadays it is not required almost. Then MCP, compressor is required because all our operation is pneumatic and electro-pneumatic. So compressor pressure is too much required. There are 3 compressor, MCP1, MCP2 and MCP3. And also our air brake system is also, this compressor pressure is required. For vacuum we need MPP1, MPP2, and for air brake we need MCP1, MCP2, MCP3. Instead of to start the engine to raise the pantograph, we are using 110 volt DC. 110 volt DC is energizing a baby compressor. It will create the sufficient compressor pressure to raise the pantograph, and the pant will be raised. DJ will be closed with this compressor pressure of baby compressor, compressed air pressure of baby compressor. Once the loco will start, then it is not required. This 100 volt DC also is used for control circuit. Control circuit are mainly electromechanical and electromagnetic circuit, electromechanical and electro-pneumatic. So this is the system. This is the auxiliaries, and traction motor using 650 volt. So now you can see how the Arno will get started. Okay, see how. So you are able to see that when the Locopento circuit breaker is closed, then the starting resistance is switch is closed and a phase difference is generated and the Arno motor has started to rotate. Then the resistance has been cut, and but the Arno is always rotating to give power supply, three-phase power supply to the auxiliary motors. So this is the system. We are receiving 25 kV from OIC conductors through the Pento. Then there is a vacuum circuit breaker just above the Locopento roof. If you close it, it is called DJ. If you close the DJ, the power will be fed to the main winding of the locomotive transformer. So one end is 25 kV from Pento end and another end is connected to the earthing point to the body and wheel to the railway track. As it is in zero potential, the other end, nobody will get shocked. Okay. So this is the system, and if the return path is cut and protection is there, it will act. So no harm will occur. Then from this main transformer, we have taken three power supply. One is 650 volt for traction motor, another is 650 volt for traction motor, and another is 380 volt for auxiliary motors. So these three supply you are taking. The auxiliaries are all three-phase induction motors, and they are cooling mainly the traction transformer and traction motors, traction transformers and traction motors, traction transformer oil. So this is the system, and also the silicon rectifier. It is experiencing a huge amount of temperature. So this is our electric locomotives. According to the horsepower of the electric locomotive, it will take current from the OHE. You convert it into kilowatt from horsepower, then you can find it by divided by 25 kV. The main transformer, the current taking by main transformer, you can find it out easily. And the other current, normally the traction motors current rating also I will tell you with a chart, so that you can understand what is the amount of current for various locomotives. Okay, thank you friends. Today up to this. Good night.